10.43, good complex gas laws problem. Lots of data. Chlorine is widely used to purify municipal water supplies and treat swimming pools. Suppose that the volume of a particular sample of chlorine gas is, so now we're given a volume to start with, so organize your data, 8.70 liters, at a pressure of 895 torr, and we're given a temperature of 24 degrees Celsius. And don't forget, add 273 to that right away. And get it into Kelvin. Let's see, then we're at the question, how many grams of chlorine are in the sample? So we're going to look for mass now. So we can use PV equals mass divided by molar mass times RT. And we're going to look for mass right here. You could also just solve for moles, and PV equals nRT, and then convert from moles to grams. But this one will allow us to directly convert to or calculate mass. So let's multiply this side of the equation then by capital M and divide it by RT, because that'll get rid of those variables. And then we have to do the same thing to this side. So then our mass ends up equaling PV times M divided by R times T. So the pressure, 895 torr. The volume is 8.7 liters. The molar mass is chlorine gas now. So look on your periodic table, and chlorine gas is 35.5 when you look right here. But remember, chlorine is diatomic, so 35.5 times 2 is going to give you about 71 grams per mole. And then the R has got to match the variable for the pressure, so we'd use 62.4 torr times liters per mole times Kelvin. And then the temperature's got to be in Kelvin, which is 297 K. All right, lots of things to stuff into your calculator there. And then once you run that all together, I believe you end up with approximately 29.8 grams of chlorine gas. So that's part A. Now part B, they want you to do a lot of initial and final condition types pieces. So it says, what will the volume be, or what volume will the chlorine occupy at STP? And letter C, at what temperature will the volume be? And then letter D, at what pressure will the volume equal? So these are all ones where you're going to have initial and final conditions, and you're going to have to figure out what the final position is. And in this case, for letter B, it's volume. So let's set that up for pressure, volume, and temperature. Now the number of moles of gas are going to remain the same, so we're not going to have to take that into account. And then we're going to have some initial conditions and some final conditions. And so initially, remember, we have 8.7 liters. I'm just going to drop the variables right now because they're going to be the same. The pressure is 895 torr to start with. And then the temperature, remember, is 297 K to start with. The final then is going to be STP, which stands for standard temperature, which of course is 273 Kelvin, or 0 Celsius. And then pressure is going to be, let's see, we're in torr, so 760 torr. And the volume is our unknown right here. So P1 V1 over T1 is equal to P2 V2 over T2. That's one way to solve it that you can set up. And then lots of people like to just put the variables or put the numbers in and then solve for it later. Or you could solve for volume 2 right away right here by multiplying both sides by T2 over P2 on this side. And what you do to this side, of course, you have to do to the other side. So T2 over P2 right here. The T2s will cancel, and so will the P2s. And so our final volume, our volume 2, will equal T2 times P1 times V1 over P2 times T1. And so our final temperature right here is 273. I'll put the units in now since we're going to do the whole math part. The pressure initially, or the pressure let's just start with, is 895 torr. The temperature, I'm sorry, the volume initially was 8.7 liters. Our pressure in the end is 760. And our temperature at the end is 273. So now you can see that the kelvins cancel and that the torrs cancel, and so you're going to end up with your answer in liters right here. And if you run that through your calculator right there, you should end up with 9.42 liters is what that gas will occupy. All right, letter C, we have a similar situation, initial and final conditions, pressure, volume, temperature. So let's set that up again, PVT, initial, final. And in this time, it says what temperature will the volume be? At what temperature will the volume be? So this is the new volume right here, and then here is the new pressure. So initially, once again, we have a pressure of 895, a volume of 8.7, and a temperature of 297 Kelvin. Our final conditions are given to us in the problem right here, where the volume would be 15 liters, and the pressure would be 876. Notice how they make that tricky by putting it times 10 to the 2, so just 2 over is 876. And then it says at what temperature will this be? So we're solving for T2 right here. So another way to do this is to take your temperature right here, and you can write 297 Kelvin, put a multiply sign, put a line, and then just look at each relationship separately, and knowing that volume and temperature is the television relationship. If one goes up, the other one goes up. You have to multiply by a ratio to make it get larger. And the ratio to make it get larger would be 15 over 8.7. I mean, your choices are 8.7 over 15, which would be like 1/2, or 15 divided by 8.7. And of course, this is going to make it larger. So the volumes here would cancel. And then look at this relationship with pressure. So look at those separately. And temperature and pressure are directly proportional as well, because one goes down, the other one goes down. And so notice my pressure is going down, therefore my temperature has to go down. So multiply by a ratio or a fraction to make it get smaller, which would be 876 over 895. And since both of these are in torr, the torrs, of course, would cancel with one another. So now multiplying those guys together, you'd end up with 501 Kelvin for your temperature. And then letter D, the last one, same type of setup where we have PVT and then initial and final conditions once again. I'm going to scoot this up a little bit so you can see a little bit closer. And our initial pressure once again would be 895. Our initial volume would be 8.7, and our initial temperature would be 297 Kelvin. And it says at what pressure, so now we're looking for pressure right here, will the volume equal 5 liters? So 5 liters right here at a temperature of 58 Celsius. So remember, don't keep it in Celsius. Go to Kelvin. So 58 plus 273, I believe, equals 331 Kelvin. So we're going to go up in temperature right here. So let's do P1 V1 over T1 is equal to P2 V2 over T2. And then let's solve for pressure number 2. So we'll multiply both sides by T2 over V2. So this side will be T2 over V2, like that. Notice how these cancel with each other. And now my pressure is equal to, this is my pressure 2, my final pressure, would be equal to T2, which is right here, 331, times my pressure 1, which is 895, times my volume 1, which is 8.7, and then divide that by my V2, which is my final volume is 5 liters times T1, which is my 297. All right, I just barely fit that in there. If you run that through your calculator, then you end up with about 1730 torr, and doesn't tell you to convert it, but this is the same as about 2.28 atmospheres. 2 ways to solve lots of problems.